Welcome to True Projects. In this video, we are going to explain about the project title and enhanced network security using machine learning and behavioral analysis. Introduction. The project addresses the growing concern of cyber attacks and the necessity of a robust intrusion detection system (IDS) to safeguard network infrastructure. With the increase in cyber threats, there's a crucial need to monitor and detect any unauthorized or malicious activities within a network. The project proposes an advanced security system that integrates supervised machine learning algorithms and feature selection techniques. This hybrid approach aims to effectively differentiate between normal, benign, and potentially harmful malicious network traffic. By using machine learning algorithms and feature selection methods, the system can learn patterns of both benign and malicious activities, enhancing its accuracy in detecting intrusions. The performance of the proposed model is assessed using the NSL-KDD dataset, a widely used benchmark dataset in the field of intrusion detection. The evaluation reveals that the model outperforms existing methods in terms of its success rate in identifying intrusions, demonstrating its effectiveness and superiority compared to previous approaches. The project delves into the utilization of specific machine learning algorithms like support vector machine (SVM) and artificial neural network (ANN) for the purpose of network intrusion detection, specifically focusing on detecting cross-site scripting (XSS) attacks. This highlights the application of different algorithms to target specific types of cyber threats, showcasing their effectiveness in addressing the distinct security challenges. Lastly, the project emphasizes the broader potential of machine learning in various practical applications, particularly in quickly identifying and predicting malicious scripts. It highlights the efficiency of machine learning in rapidly analyzing and responding to potential security threats, underscoring its significance in enhancing network security measures. Objective of the project is: the primary aim of the project is to create a more robust network security system. This system employs machine learning and behavioral analysis techniques to categorize network traffic into two categories, malicious or benign. By making this classification, the system endeavors to ensure the overall security of the network, identifying and mitigating potential threats before they can cause harm. The project concentrates on utilizing supervised machine learning algorithms along with feature selection methods. Supervised learning involves training a model on labeled data, allowing it to learn patterns and make predictions. Feature selection methods aid in choosing the most relevant and informative features for the model. This focus on both supervised learning and feature selection aims to create an optimized model for effective intrusion detection. To assess the performance of the proposed model, the NSL-KDD dataset is used for evaluation. This dataset serves as a benchmark for evaluating intrusion detection systems. The project includes a comparative study where the efficiency of the proposed model is measured against existing models. This comparison is crucial in demonstrating the superiority or improvement of the developed system in terms of its success rate in detecting intrusions. The project's overarching goal is to create a highly accurate identification system capable of effectively detecting and mitigating malicious cyber threats. Importantly, this system is designed to operate at both individual host levels and on a broader community scale. This implies that the system aims not only to protect individual devices but also to contribute to the security of the entire network community by detecting threats that might affect multiple nodes or systems. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This step involves importing necessary libraries or packages in the chosen programming environment like Python. These packages include tools for data manipulation such as pandas, visualization like Matplotlib and Seaborn, machine learning frameworks such as Keras, and other utilities necessary for data analysis and modeling. Exploring the dataset NSL-KDD. Here, the dataset named NSL-KDD is explored. This includes loading the dataset into the programming environment and examining its structure, size, data types, summary statistics, and initial patterns. This exploration helps in understanding the data before processing or modeling. Data processing, Pandas data frame. The dataset is converted into a Pandas data frame, a popular data structure in Python for data manipulation. This facilitates easy handling and manipulation of the dataset. Keras processing. Specific pre-processing steps are performed using Keras, a deep learning library. These steps involve data normalization, scaling, or encoding suitable for neural network models. Dropping unwanted column. Some columns which do not contribute to the model's predictive power or which contain redundant information. Dropping such columns helps streamline the dataset and reduce noise. Visualization using Seaborn and Matplotlib. Data visualization is crucial for understanding patterns, relationships, and distribution within the dataset. Seaborn and Matplotlib are used to create visualization such as histograms, scatter plots, heat maps, etc. to provide insights into the data. Label encoding using label encoder. In machine learning, categorical data often needs to be converted into numerical format for models to process them effectively. Label encoding, performed using tools like the label encoder from scikit-learn, converts categorical variables into numeric format, assigning a unique numerical label to each category. Feature selection. Select percentile using mutual info classify. Feature selection aims to choose the most relevant and informative features for the model. Select percentile is a method from scikit-learn that selects the top features based on a specified scoring function, such as mutual information classification, which measures the dependency between variables. Splitting the data to X and Y for machine learning. This step involves dividing the dataset into input features X and target variable Y. X contains the independent variables used for prediction, while Y contains the dependent variable that the model aims to predict. Building the model. This phase involves constructing the machine learning or deep learning model. Depending on the project's objectives, this involves creating a supervised learning model and training it on the process data to predict network security related outcomes. Training the model. This step involves feeding the prepared dataset into the chosen machine learning algorithm. The algorithm learns from this data, adjusting its parameters to create a predictive model. Training involves iterations through the dataset to optimize the model's ability to predict the target variable accurately. Flask framework with SQLite for sign up and sign in. Flask is a micro web framework for building web applications in Python. Integrating Flask with SQLite allows the creation of user authentication functionality such as sign up and sign in. SQLite is a lightweight relational database management system often used for local storage in web applications. These components enable user account creation, authentication, and storage of user information securely. User gives input has feature values. In this phase, users provide input relevant to the network traffic features. This input includes various parameters or characteristics related to the network traffic that the system requires for prediction. The given input is pre-processed for prediction. The input provided by the user needs to undergo the same pre-processing steps applied to the original dataset. This ensures consistency and compatibility with the model. Pre-processing steps involve encoding categorical data, scaling numerical values, and arranging the input in a format suitable for prediction. Trained model is used for prediction. Once the user input is pre-processed, the trained machine learning model is employed to predict whether the input corresponds to benign or malicious network traffic. The model utilizes its learned patterns and relationship to make this prediction based on the provided input. Final outcome is displayed through front end. Finally, the prediction outcome, whether the input corresponds to benign or malicious network traffic, is displayed to the user through the application's front end. This could be presented as a message, visual indicator, or any appropriate representation conveying the security status of the provided input. Algorithms used to implement this project, we have utilized the following algorithms. The first algorithm is SVM, Support Vector Machine. SVM is a supervised learning algorithm used for classification tasks. It works by finding the optimal hyperplane that best separates different classes in a high-dimensional space. In network security, SVM can classify network traffic as either malicious or benign based on learned patterns and feature representation. SVM is known for its effectiveness in handling high-dimensional data and its ability to handle both linear and non-linear classification tasks with appropriate kernel functions. Navy Bayes. Navy Bayes is a probabilistic classification algorithm based on Bayes' theorem with an assumption of independence between features. Despite its simplicity, Navy Bayes is effective in various applications, including text classification, spam filtering, and intrusion detection in network security. It computes the probability of a data point belonging to a particular class given its feature and selects the most probable class. Random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training and outputs the class that is the mode of the class's classification or mean prediction regression of the individual trees. In the context of network security, random forest can handle large data sets, maintain accuracy with noisy data, and provide insights into feature importance, aiding in identifying critical features for intrusion detection. ANN, Artificial Neural Networks. ANN are a class of machine learning models inspired by the structure and function of the human brain. They consist of interconnected nodes organized in layers. In the context of network security, ANN can learn complex patterns from network traffic data, making them suitable for intrusion detection tasks. Deep learning models, a subset of ANN, have shown promise in detecting sophisticated and evolving cyber threats. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Comparison graph. Comparison graphs offer a visual breakdown of how our model performs across essential evaluation metrics. These are the comparison graphs of NSL KDD dataset. Models are compared with the parameters accuracy, precision, recall, and FN score. This is the accuracy comparison graph. Here on the x-axis we have accuracy score and on the y-axis we have algorithm name. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. This is the precision comparison graph. On the x-axis we have precision score and on the y-axis we have algorithm name. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positives plus false positives. This is the recall comparison graph. On the x-axis we have recall score and on the y-axis we have algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the FN comparison graph. On the x-axis we have FN score and on the y-axis we have algorithm name. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing users' requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file, which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, this localhost, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome. So I'm pasting the copied link and click on enter. So here we can see the homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered. So click on sign in. Here we need to enter the username and the password which we have created and then click on login. We have logged in successfully. So here we need to enter all these parameters to predict whether attack is detected or not. So I'm entering the parameters now. So here I have entered all the parameters value. The first one is service, which is 24. Service is the type of service or protocol used in network communication. Flag is 5. Various states in network packets indicating potential anomalies. SRC bytes is 0. Source bytes. Bytes sent from the source in a network transaction. DST bytes is 0. That is destination bytes. Bytes received by the destination in a network transaction. Count is 287. Frequency or count of a specific network, event, or transaction. Error rate is 1. Source error rate, percentage of source connections resulting in errors. SRV error rate is 1. Server source error rate. Error rate specifically from the server end. Same SRV rate is 0.02. Same server rate, percentage of connections to the same server. Different SRV rate is 0.06. Different server rate, percentage of connections to different servers. Different host SRV count is 5. different host server count, count of connections to different servers from different hosts. DST host same SRV rate is 002. Destination host same server rate. Percentage of connections from the same host to the same server. DST host different SRV rate is 0.02. Destination host different server rate. Connection from the same host to different servers. DST host error rate is 0.07. Destination host source error rate. Error rate from the destination host. DST host SRV error rate is 1. Destination host server source error rate. Error rate specifically from the destination server to the host. These parameters collectively form a set of metrics used in analyzing network behavior for enhancing security through machine learning and behavioral analysis. After entering all these parameters, click on Predict button. So here we can see we got the result. There is an attack detected and attack type is DDoS. That is distributed denial of service. Now we will enter another set of parameters and check whether attack is detected or not. Click on Home button. So here I'm entering another set of parameters now. So here I have entered another set of parameters. Now click on Predict button. So here we can see we got the result. There is no attack detected. It is normal. Now we will upload another set of parameters. So click on Home button. So here I'm uploading another set of parameters now. So here we have entered another set of parameters. Now click on Predict button. So here we can see we got the result. There is an attack detected and attack type is probe. Now we will enter another set of parameters and check whether attack is detected or not. So click on Home button. So here I'm entering another set of parameters now. So here I have entered another set of parameters. Now click on Predict button. So here we can see the result. There is an attack detected. Attack type is R2L. Now we will enter another set of parameters. So I'm entering the parameters. So here I have entered another set of parameters. Now click on Predict button. So here we can see the result. There is no attack detected and it is normal. In this way, by entering the parameters, we can predict whether attack is detected or not. And if attack is detected, what type of attack is detected? DDoS, R2L, probe, or normal. Now click on Sign Out button. Conclusion of the project is the proposed system, which integrates machine learning and behavioral analysis techniques, showcases its capability to accurately classify network traffic into two categories, malicious or benign. This accuracy is vital for swiftly identifying potential threats and distinguishing normal network behavior from potentially harmful activities. Through the comparative study conducted using the NSL-KDD dataset, the proposed model demonstrates superior performance compared to existing model in terms of its ability to detect intrusions. Its higher intrusion detection success rate signifies its effectiveness in identifying and mitigating security breaches within the network more accurately than previous approaches. The project underscores the significance of developing precise and sophisticated identification systems to counteract malicious cyber threats effectively. Accurate detection is crucial in preventing potential attacks and minimizing the impact of security breaches on network infrastructure and data. Utilizing supervised machine learning algorithms like support vector machine SVM and artificial neural network ANN significantly contributes to the success of the proposed model in detecting and predicting malicious scripts specifically targeting XSS attacks. These algorithms learn patterns from labeled data, enabling them to recognize and classify malicious scripts with higher accuracy. The project places a spotlight on the immense potential and impact of machine learning in practical applications, especially within the domain of network security. By highlighting the effectiveness of machine learning techniques in addressing security concerns and swiftly identifying potential threats, the project underscores the importance of leveraging these technologies for enhancing network security measures.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.